This problem asks us to consider general curvilinear motion of a particle. We've got a particle. It's traveling from A to B to C to D. And we know something about the geometry of those path segments that the particle is going to travel along. We also know something about the time it takes for the particle to travel along that path. So from A to B we have 2 seconds, B to C is 4 seconds, C to D is 3 seconds. And our goal here is to determine the average speed when this particle travels from A to D. So when we're talking about language like average speed, what we're really doing here is we're considering something like total distance traveled divided by total time that it takes to travel that distance. That being said, the approach is then pretty straightforward. So the first thing we want to do here is write out an average speed equation. Okay, and that average speed equation is going to be something like V average equals to the total path traveled, S total, divided by the total time, T total. And then in step 2, what we're going to do is we're really just going to focus on the thing in that equation that we don't know, and that is S total. And we're going to calculate S total using a scalar approach. Okay, so this is actually a reasonably straightforward problem. Let me make some observations about what we know first. You notice that here from B to C we know the length of the path is 15 meters. And then you notice that from A to B and from C to D are these quarter circle paths, and we know the radius of the circle in each of those cases. So really this is going to be a pretty straightforward way to go. Let me just go ahead and write step 1 right here on this page so you can see it. Step 1 is we're going to do average speed equation. Okay, we already know that that's going to include S total and T total. And so S total, just to be explicit about it, is going to be the path from A to B plus the path from B to C plus the path from C to D. And let me emphasize that this one, from B to C, we already know this is just equal to 15 meters. Okay, really, so the hard work in step 2 is confined to segments A, B, and C, D, and that's what we're going to do next. So step 2 is to calculate S total using scalars. Now I say they're using scalars as opposed to using vectors because the scalar approach is just much more convenient because we know that the geometry of the path is a circle. So let me go back to the picture here. And in blue, let me outline that path. So here's from A to B. So that is 1/4 of the circumference of a circle. And so that's going to be an easy enough thing to calculate. So let's go back over here and actually make that calculation for segment AB. We know we're going to get SAB is equal to the circumference of the circle. That's 2 times pi times the radius. And that's going to be divided by 4 because it's a quarter circle. So this is 2 times pi times 10 meters divided by 4. This turns out to be 5 pi meters. From C to D we can make the same kind of calculation. S from C to D is equal to 2 times pi times the radius on that segment divided by 4. And that's just 2 pi radius of 5 meters divided by 4. This turns out to be 5 pi over 2 meters. So we add that all up. S total is going to be 5 pi plus 15 meters plus 5 pi over 2 meters. Okay, so just to be clear here, this is segment AB, this is BC, that's CD. That all ends up, once we do the math, adding up to 38.56 meters, and that means if we use our average velocity equation, we get V average is equal to S total divided by the time total, so that's 38.56 meters divided by the total time. Let's go back to the problem statement. The total time is given by 2 seconds plus 4 seconds plus 3 seconds. That's 9 seconds is the total time as given in the problem statement. So that means we put 9 seconds down in the denominator there, and we end up with 4.28 meters per second. And there is your answer for the average velocity of the particle. Let's review what we did. So we have a particle traveling along a curved path, and our goal here is to determine the average speed. And the average speed equation is easy enough to come up with. It's the total length of the path traveled divided by the total time it takes to travel along that path. So the equation is pretty straightforward, and in this case, the hardest part of the problem was determining the path length from A to B and from C to D. Once we recognize that those are just quarter circles, we can go ahead and use our circle equations to figure out what those path lengths are and come up with the final solution for the average velocity, 4.28 meters per second.